Hello everyone, I'm Harsha. My other teammates are Akhila, Bharath and Ravi Teja. As a part of the mobile computing course, we implemented a prototype of biometric feature identification of desktop users on the basis of mouse patterns. This idea was a part of the research component that we have discussed in the class. The entire demo can be broadly classified into 4 areas. First, collection of the data. Second, data processing. Third, training of the data. And fourth, identification of the user. The first module, that is collection of the data, will be further explained by Akhila.
This is Bharath. I implemented the task to integrate data collected from mobile and desktop to perform processing on the obtained values. Initially, the smartphone is tied to the user's wrist as we can see in the video so as to take user-specific accelerometer values. For the demo purpose, we are training for 4 different users named user 1, 2, 3 and 4. By pressing the user 1 button, we started collecting accelerometer values for the first user. Data is collected for 5 seconds and stored in the database. This process is repeated multiple times for each user, and in this case there are 4 users.
Hello everybody, I'm Akhila Polishetty, and the module that I've implemented for this project consists of 2 parts. It's a desktop application and a mobile application. For the desktop application, what I've done is the purpose behind doing this desktop and mobile is, in our application, along with the accelerometer data, we also need the user's mouse patterns on the keyboard of his desktop in order to identify who he is. As you can see, the first applet that I'm scrolling over is used for the socket connection establishment between the mobile and the desktop. As you can see, in the first column I can enter anything. In the mobile application, it displays the IP number and the port number that I'm supposed to connect to. Here, once I type the same IP number and the port number, as you can see, the second applet helps me collect the data of the user's movement. But once I scroll here, before even I establish the connection, nothing happens. But once I press the connect button and move my button here, I can collect the user's movement, and on the on our mobile application, this is a module of our mobile application, you can see the data has been printed. This printing is for the demo purposes. This data we take it from this mobile and then append it to our old accelerometer data and use this as a training set for our model for user recognition.
We have seen socket module explained by Akhila. When we press the next button over here, we can see socket module where the mouse pointer data is received. I further implement the module that integrates data obtained from accelerometer in mobile and the desktop mouse received through the socket. We create a database with each line consisting of 5 seconds of user data. Note that the raw data from the sensors cannot be directly fed to the classifier. It has to be of a specific format, and we are arranging data accordingly into that particular format that can be processed by the classifier. As you can see in the video, we check the database file by pressing display text. The first digit 0 is a class label, and next are all the accelerometer values appended with the mouse pointer values. When we press train, the SVM classifier takes in training data generated by 4 users and a model file is generated from it. We can see the model file. These are all the parameters obtained from the SVM classifier train. More detailed information regarding SVM classifier and training will be given by Ravi.
Hi, I'm Ravi Teja. To authenticate a user, he or she is identified by 3 distinct features, which are: first, the speed with which he moves his hand. The speed of the hand movement is proportional to the acceleration values in X, Y, and Z dimensions, which are recorded and stored by the accelerometer sensor in the mobile. The orientation of the rotation of the hand or the angle of curvature for various points on his movement. This is the second feature vector. When a user moves in between 2 points, the angle of curvature differs when moving from left and when moving from left to right. This is a huge change with respect to the user behavior pattern. For example, the user might move from B to A in this direction or in this curve. Similarly, he can move from right in this direction or in this For example, if we observe, the angle at each point varies along the path. So, all the points are calculated and stored in the database. The area on the desktop where he moves the mouse pointer. This is the third distinct feature which we are taking. All these data have been stored in the database for each specific user as explained by Bharath. Now, we need to build a predictive model based on the data we collected. For this purpose, we built a robust machine learning model using support vector machines with about 300 feature vectors and 4 labels who are the users. The high number of dimensions are taken to nullify the error pertaining to small changes. The raw data cannot be directly given as an input to the classifier. All these features are extracted and the classifier is built. We perform k-fold cross-validation to find out the overall accuracy of this model.
For the identification of a new test user, hit the Identify button on the smartphone. Now, and maneuver the mouse as you do normally on a daily basis. The system collects the data from the PC, smartphone, which is integrated, stored and processed as mentioned previously. This test data is again fed to the classifier, which classifies the test user and authenticates accordingly. Note that this same name is displayed in the real time on the basis of the outcome of the classifier. As you can see here, this information is obtained through the socket from the mobile applet. Note that the prediction might not always be true, as the overall accuracy is only about 50% for now. This accuracy is bound to increase with an increase in the training data, which we will be collecting over the next week. Hence, the expected final accuracy would be around 60 to 70%. And concluding this, we have finished about 90% of the project work is done, and the remaining 10% would be to create a dynamic user interface. For example, as we have taken only 4 users, I think we can make it into, as the users increases, we can change the UI.